This is how the hypothesis testing intuition works. Similar to a judgment session, we're going to listen to the both sides. So we're going to see that what H naught statement is. It says that this is the example from the average salary. It says that the average salary in the population is equal to $66,300. We also listen to the other side. The alternative hypothesis states that the average salary is not equal to $66,300. We hear you both. Now, similar to a judgment session again, we're going to base our judgment on evidence. So in hypothesis testing in statistics, evidence is based on a sample. Since we do not have access, we do not really know the truth here. We do not really know what the population parameter is here. Here is the average salary. So instead, we're going to take evidence. The evidence is we're going to take a sample from this population. So we're going to take a sample of people who are in this population, and we compute the average salary of those sample. And if the sample mean, if the sample average is sufficiently close to the claim stated in the null hypothesis, we're going to accept the null hypothesis and judge in favor of it. Otherwise, we're going to reject the null hypothesis credibility statement, and we're going to vote in the favor of the alternative hypothesis. Suppose that the average salary or the salary is a random variable in this population under study that would follow a normal distribution. So the null hypothesis that the average of this population is equal to $66,300. So this is a bell-shaped normal distribution that you see, and the average of it, which is in the peak here in the center, is equal to $66,300. Okay, so we say that, okay, the null hypothesis, we hear you. Now we're going to take a sample. Suppose that we take a sample and we computed the average of the sample equal to $62,577. So since this value is not really close to the average of this population, so it's technically unlikely that the null hypothesis statement was true if based on the evidence that we have, because this value, the average sample, is unusually far from the claim stated in the null hypothesis. But as you see here, this is kind of vague. We need to define what does it mean to be far and what does it mean to be sufficiently close. Okay, so we need to quantify that to make it more clear. But the intuition is this. The intuition is that we take a sample, we compute the sample statistics, whether it's average or proportion, and then we compare this whether it is close or not, sufficiently close or not, based on whatever we define as close or not. And if it's close enough, if it's in the acceptable range, then we're going to accept the null hypothesis. Otherwise, we're going to reject the null hypothesis. So this is the general intuition of hypothesis testing in statistics. When to accept the null hypothesis? Here we want to talk about a guideline in decision making in hypothesis testing, so that it would help us to make the right decision based on the evidence that we gathered, which is based on the test statistics of a sample that we have, which we're going to talk about it later on. So we're going to identify the regions, acceptance region and rejection region, such that if the value of test statistic falls in the rejection region, we're going to reject the null hypothesis. On the other hand, if the value of test statistics falls within the acceptance region, we're going to accept the null hypothesis. This is a two-tailed test, which we're going to talk about it later on, but just for a brief introduction, in the two-tailed test, we're going to have two rejection regions. One is on the right side or the right tail, and one is on the left side or the left tail or lower tail. The region that you see here and also on the left are the rejection region. So we have two critical values here. Suppose that we are talking about a z-test here. So this is z of alpha over 2, which is the z-value of the probability of alpha over 2. And this is the mirror image of that, the z of negative alpha over 2. So for these two critical values, if the value of test statistics falls in these regions on the left or on the right, we're going to reject the null hypothesis. Otherwise, if the value of test statistic falls within this green range, we're going to accept the null hypothesis. So if the test statistic value, which is based on the sample, here we are talking about the average, and the test statistics is x bar minus mu. This is the parameter mu, is the population parameter average, divided by sigma over square root of n. So if this value, which is the z stat test value, if this value falls between the two critical values, one here and one here, this is z of alpha over 2 again, this is z of negative alpha over 2. If the test statistic value falls between these two, that means within the green region, we're going to accept the null hypothesis. Otherwise, we're going to reject the null hypothesis. So this is the general guideline. Based on the value of test statistic and also the critical values, we would either reject or accept the null hypothesis. 6 steps in hypothesis testing. The steps that we're going to talk about here is going to be applied to any type of hypothesis testing that you do, regardless of the parameter, whether it is a mu or proportion, or whether it's actually a two-tailed test or one-tailed test, as we're going to learn later on. So the first step is to identify and assert the null and alternative hypothesis. You need to identify what should be the statement, what should be the assignment that should go for the null hypothesis, which actually represent the status quo, and also what's going to be for the alternative hypothesis. And always have to remember that these two alternative and the null hypothesis, these two hypotheses confront each other. They oppose each other. After you have stated the null and alternative hypothesis, you have to pick the level of significance or alpha that you want to test these two hypotheses, and also the size of the sample that you want to take the sample, and that's going to be your evidence. The third step is to determine the appropriate test statistics or the method to use, and also the sampling distribution, whether it's a z-test, whether it's any other types of distribution. And after that, you need to determine the critical values that would define the acceptance and rejection region. The fifth step is to compute the test statistic value based on the sample that you have taken, and also the observed value of test statistics based on the whatever parameter that you have had. And the last steps, the sixth step, is to make the statistical decision whether you would accept or reject the null hypothesis based on the test statistic value and the acceptance and rejection region set aside by the critical values. So if the test statistic value falls in the acceptance region, you're going to accept the null hypothesis. Otherwise, you're going to have to reject the null hypothesis in favor of the alternative hypothesis. One-tailed test in hypothesis testing. The hypothesis testing that we have studied so far have been a two-tailed test. That means we have had two rejection regions on both sides or both tails of the distribution. However, there are other types of hypothesis testing, including the one-tailed test, the lower tail test, and upper tail test. Let's go back to our hypothesis testing that we studied before. So in the null hypothesis, we had equality sign. So for example, mu, the average of the population, equal to 3. And then the alternative hypothesis would say that no, the average is not equal to 3. So because we have inequality in the alternative hypothesis, that means that we have actually two rejection regions on the both sides or both tails of the distribution. These are the rejection region on the left and the right. However, in one-tail hypothesis testing, we have a situation in which we only have one rejection region either on the left or right. This is what we want to study now. For example, this hypothesis test. The null hypothesis states that the average of the population mu, the parameter, is greater than or equal to 3. And the alternative hypothesis says that no, the average mu is less than 3. So this is different from what we had before. This is not inequality. Inequality can be when something is not equal to something else, that means that it's either greater than or is less than. So it's both directions works. But here, only one direction. So when something is less than something, that means that it's less than. So in this situation, we have a one-tail test, and our rejection region based on the inequality sign on the alternative hypothesis here is going to be on the left. It's going to be less than that. So that means that our rejection region is going to fall on the left. So we're going to have a one-tail test because we have one rejection region. So this is a lower tail test since the alternative hypothesis is focused on the lower tail below the mean. So again, I would like to get your attention on the lower tail here. The lower tail comes from the inequality less than in the alternative hypothesis. On the other hand, we can have the other way around. So here in this hypothesis testing, we have the null hypothesis states that the average of the population mu is less than or equal to 3, and the alternative hypothesis says that is greater than 3. So this is the opposite of what we had here previously. So here again, we only going to have one tail test. We're going to have only one rejection region, and this time is going to be on the right or the right tail. So that's why we call it the upper tail test. So this is an upper tail test since the alternative hypothesis is focused on the upper tail or the tail on the right or the rejection region on the right side of the distribution. So again, the side or which side of which tail of the distribution is the rejection region is going to be determined by the inequality sign, whether it's less than or greater than. So here is greater than, that means that it's on the right side, it's on the upper tail. So this is a one tail, upper tail hypothesis testing. When it comes to hypothesis testing and a lot of other topics in statistics, there are different notation convention based on different resources and textbooks. For example, some books, they call the rejection region as reject H naught and the acceptance region as the not rejecting H naught. And some say the acceptance H naught for the acceptance region and do not accept H naught for the rejection region. But nonetheless, the conclusion would be the same, to either reject H naught or accept H naught. So this is a lower tail test. As you can see here, the alternative hypothesis, there is less equality. So that means that the rejection region is on the left side or the lower tail here. In lower tail test, there is only one critical value and one rejection region, and it's going to be on the lower tail or on the left. As you can see here, we have one critical value. Since we are dealing with a z-test, test statistics, we're going to have one critical value on the left, and the rejection region is on the lower tail or the left because the inequality sign is less than in the alternative hypothesis. So there is only one critical value since the rejection region is only on one tail in lower tail test. In upper tail test, we again have one critical value and one rejection region, but this time is on the right. So we are using a z-test statistic, so we're going to have a z-value, critical value on the right tail, and the rejection region is on the right. Again, this is z of alpha, and it's not z of alpha over 2, that the case that we had in a two-tailed test. So since in the alternative hypothesis we have greater than, that means that the critical value and the rejection region is on the right tail. In hypothesis testing in statistics, we can have two-tailed test or one-tailed test. Here is an example of a two-tailed test which we previously observed. As you can see here, we have two rejection region and one acceptance region in the middle. So whether we have a two-tailed test or a one-tailed test depends on the null and alternative hypothesis. As you can see here, in this example, our null hypothesis, we have equality. And in the alternative hypothesis, we have inequality. So when you have inequality, you're going to have two rejection regions, one on the right and one on the left. So this is going to be a two-tailed test. So if you have inequality in your alternative hypothesis, then you're going to have a two-tailed test. If you don't have inequality in your alternative test, or if you don't have equality in your null hypothesis, then you would have a one-tailed test, as we're going to talk about it later on. In a two-tailed test, we have two rejection regions, one on the left and one on the right. And if the test statistic value falls in this rejection region, we're going to reject the null hypothesis. Otherwise, if it falls in the acceptance region here, then we're going to accept the null hypothesis. Now let's do an example. Hypothesis testing for testing a hypothesis regarding the population average. So similar to the situation that we have for confidence interval, we can actually have two scenarios. One scenario is that we know the standard deviation of the population, and the other one is the standard deviation of population is unknown. So we are only going to cover the first scenario, which is the standard deviation of the population is known. When this scenario is considered, we can actually use the z-stat, the z-test, as the test statistic. So this is the formula for the test statistic value, which is actually the z-value of x bar. So that's x bar, the average of the sample, minus mu, which is the value of the population average stated in null hypothesis, divided by sigma over square root of n. So this is the test statistic that we're going to use to test the validity or the invalidity of the null hypothesis.